Assalamualaikum warahmatullahi wabarakatuh, Dr. Jainah. My name is Muhammad Irfan Shazmin bin Jamaluddin. My matrix number is A176956. So today, I will give a brief based on my project, which is application of hybrid system between fuzzy logic and fertigation system in crop field, chili plants. This is based on my final year project 2023. Okay, so what is fuzzy logic? Fuzzy logic is an AI algorithm that attempts to solve problem with an open, imprecise spectrum of data to obtain an array to accurate conclusions. How about fertigation system? Fertigation system is an application whereby fertilizer is being pumped into farming plants via irrigation network. So first, I will give a short brief about the introduction based on my final year project. In my final year project, the fertigation system was designed to allow organic fertilizer, which also I made, organic fertilizer, to flow into the crop, the feed crop. So this fertigation system use a timer to supply the fertilizer as scheduled. So the time intercept between the between pump is about 3 hours. So at 10 o'clock, we pump about certain volume of fertilizer, and about 1 o'clock we pump again. So in this study, I will develop fuzzy logic and fertigation system interaction as hybrid system. So what is the problem statement? The problem statement here is the lack of quality data. This is the key hurdle for many farmers, as sensors reading from the field, weather reports and farm activity logs are essential for AI application. As I mentioned earlier, I used a timer which is not very valid, because sometimes there's a time where the temperature is so high that the plant needs water or fertilizer to as their source. So this is one of the challenges faced by the farmers, because the lack of data and the weather reports and activity log and so on. Another issue is that the need of technology infrastructure to support AI. In other words, to reap all the benefits of AI, first need technology infrastructure. So, the objective of this case study is to develop fuzzy logic by using MATLAB or POSOIL. So we want to observe and record the data on the soil, so that we have um, based on input such as temperature, pH, moisture, and so on. So the second one is to identify the suitability of using hybrid system between artificial intelligence with traditional farming practices, which is fertigation system. So this is the methodology based on the flowchart. Overall flowchart of the methodology consists of fuzzy logic algorithm by using MATLAB and fertigation system. So first of all, let's take a look about this flowchart. We first have to. This is two ways, because with dealing with hybrid system, there's a two components here, which is fertigation system and also the fuzzy logic here. So the fuzzy logic is quite straightforward. We generate fuzzy logic using MATLAB, and then we insert temperature, pH, and moisture content as inputs. We have three inputs and one outputs. Set up the input type of membership functions and output. The output will be the flow of the fertilizer to pump into the crop field. And the input is these parameters, which is temperature, pH, and also moisture content. So next, we have the fertigation system whereby we upgrade it, where we deploy soil moisture sensors and other IoT device throughout the fields. Such as we have to deploy pH, temperature, and moisture sensors, so that this will give a real-time value data to for our fuzzy logic sets. So collect real-time data on soil moisture level, temperature, and humidity and vertical conditions, as I mentioned here. So we will combine these two systems and automatically adjust the water flow based on the recommendation from the fuzzy logic and data of sensors by using fertigation system. So when fuzzy logic and fertigation system has been combined, fertigation system is able to pump the fertilizer based on the fuzzy logic's code, fuzzy logic's output. So for example, if we have the inputs, we have the high temperature of the day, so the more of fertilizer will be pumped throughout the crop field. Okay. Okay, this is the methodology. This is I will explain more in fuzzy logic in MATLAB. First of all, the input and the output. Three inputs and one output, which is we have temperature, pH, and moisture, and one output, which is the flow of our water or our fertilizer. The inputs are temperature, pH, moisture, okay, and then we use Mamdani. For the membership functions, we have to set it. We use trapezoidal membership function because trapezoidal allows for greater flexibility in representing fuzzy sets compared to simpler membership functions at the inlet, and Gaussian membership function at the outlet because Gaussian provides smooth transition between membership and non-membership to enhance modeling gradual in real-world phenomena. Lastly, we have to set the fuzzy logic, fuzzy rule. Sorry, fuzzy rule is consists of if and then, consists of input and outputs. I'm using n parameters to ensure that all conditions in rule must be simultaneously satisfied for the activated. Okay, this is the step by step of using fuzzy logic in MATLAB. I will show Doctor my file fuzzy logic in MATLAB later on. So first of all, we have to set the input and the output. This is the input and this is the output, and then we set the membership function, whether we want to trapezoidal, triangular, Gaussian, and so on, and number of membership functions. Because we set it as 3 because from low, medium, and high. So it's of temperature, low temperature, low moisture, and also acidic pH. And lastly, we have to set fuzzy rules. This is based on if and then. And I use n function. We have set of rules here so that you can generate output. Okay, so let's take a look on my fuzzy logic in MATLAB. So this is our fuzzy logic in MATLAB, which consists of 3 inputs and 1 output. So what the outputs here will be flow, and the inputs will be pH, moisture, and temperature, which will later on will be measured by IoT sensors and to develop hybrid system. So let's get into it. So we have trapezoidal membership function for inputs and Gaussian membership functions for the output. Okay, so we have set the range of the moisture from 0 to 100% and temperature from 20 degrees C to 80 degrees C because this is the range of the temperature in the current farm area, and also the pH. So then we have to set the rules here using n or the pH. And lastly, we can obtain the results based on rules and surface. For example, this is our rules. We have set here this is our pH, this is the moisture, temperature. So the rules result will give the outputs data, outputs value here based on these parameters. Okay. And lastly, the surface, which is we can see here. First, we have pH and also the output, the flow. If the pH is increasing, the output have to be lowered due to the chili plants need to be in alkali state. On the other hand, if we have moisture and temperature, okay, this is our graph, which is if we are increasing in temperature, so we have increasing flow and so on. Alright, as I shown earlier, from the fuzzy logic in MATLAB, and also I also show the result and discussion. You can see here, if temperature is increasing, the flow is also increasing, because we want to ensure that the plants is given enough water and fertilizer throughout the sunny day. Because if the plant is affected, it's dry up, it will dead and affect the quality of the product. Such as if I plant chili plants, so if my chili plants dry up, it will affect the chili and also the quality. Okay, this is based on the surface viewer, and this is based on the rule viewer. Alright. So for the results and discussion, based on the fuzzy logic that we have developed, we want to integrate it with fertigation system. The fuzzy logic system is incorporated into the fertigation system to control the fertilizer injection rate. The fertigation system is designed to receive the recommended fertilizer application rate and adjust the injection according to during irrigation. As I mentioned, the rate of the flow from the tank of the fertilizer into the crop field will be controlled by our fuzzy logic based on the input parameter that we have inserted in fuzzy logic sets. Alright, in conclusion, integrating a hybrid system between fuzzy logic and a fertigation system in crop management offers several advantages and benefits. For example, by combining fuzzy logic and with fertigation system, the application of fertilizer can be more precise and targeted due to, for example, if the moisture of the soil is so low, due to the temperature is high, so more water or fertilizer is able to pump without our presence. So this is more automated approach. And lastly, the advantages, the system can evaluate the current state of the soil, crop, nutrient requirement, and other variables to determine appropriate fertilizer dosage, minimizing waste, and ensuring efficient nutrient utilization. I think that's all from me. Thank you.